Hey guys, Mr. Bowman here. We've got two learning objectives in this video. The first one in white, we're learning to prove the quadratic formula. The second one in red, we are learning to solve quadratic equations using that formula that we proved. So in terms of a background, it's really important to know why are we doing what we're doing? And that's because there are three separate ways you can solve a quadratic equation. We learned you can solve it by factorizing, and you're making sure that's equal to 0. We then learned you can solve it by completing the square. And the final method you can solve a quadratic is the quadratic equation. And the cool thing about this last one is it applies to every type of quadratic you have. It doesn't matter if you can or can't factorize it. This last one will be able to work for you. So our starting point for the first learning objective is we're just trying to prove the quadratic formula. And what happens is often your quadratic will look like this. ax squared plus bx equals 0. And just an example, we've got maybe 3x squared plus 6x minus 1 equals 0. So that's an example. And in this case, that a value relates to the number in front of the x squared, in this case, the 3. The b value, that relates to whatever number's in front of the x, in this case, 6. And the c value at the end, that relates to the number sitting by itself at the end, in this case, -1. Hopefully you can kind of see where that formula ax squared plus bx plus c comes from. It's just a generic formula for all of them. And what we're trying to do is we're trying to solve this and prove the quadratic formula. To solve something, normally at the very end of our work, it needs to be x equals and whatever it is that the answer comes to. So what we're going to do is we're going to manipulate and rearrange this equation here, move a, b, and c to the other side, leaving x on that right-hand side. And the first thing we need to do is it relates to completing the square. So it relates to the second method of solving quadratics. We're just going to divide everything by a to get rid of the letter in front of the a squared. So ax squared divided by a is just going to be x squared. We're then going to plus b over ax, and then we've got plus c over a, and they combine to get 0. We're then going to look to complete the square. So this middle part, 1/2 of that is going to be 1/2 times b over a, and that's just going to become b over 2a. And then following that, we then need to square that. So we've got b over 2a squared. I'm not going to expand that bracket. I'm just going to leave it as it is. So that means we need to plus and minus the squared number from our equation. So we've got x squared plus b over ax, and we're going to go plus b over 2a squared minus b over 2a squared, and then we've got plus c over a, and that's the bit that hasn't changed at all on that side. And all of that there is still going to be equal to 0. We're then going to complete the square that relates to this portion, and we're then going to move all of this stuff to the other side of the equation just to get that out of the way. So we've got to think what two numbers multiply to b over 2a, but add to b over a. And we already know this, so we know it's going to be, inside our brackets, b over 2a. So that's going to be x plus b over 2a, and that there's going to be squared. And that's going to be equal to negative c, or negative 6, but negative c over a, which is the opposite of positive c over a. And then we've got positive b over 2a squared. We're now going to focus on that right-hand side just to simplify it up a little bit, and this is where I'm going to get rid of that bracket. So that's going to be negative c divided by a plus b squared over 4a squared. So that is b times b divided by 2a times 2a. And that left-hand side has not changed, so we're just going to leave that as it is. We're now just going to simplify the right-hand side over here. And we're going to do that by trying to manipulate the equation so the denominator is the same. And what I've realized is if we times this bit here by 4a over 4a, that will make the denominator 4a squared, which means we can go ahead and simplify that. So let's see what that all comes to. So we're going to get, we'll carry on over here, x plus b over 2a squared. And we're going to have negative c times 4a is going to be negative 4ac divided by 4a squared plus b squared over 4a squared. They've got the same denominators, so we can now add them together. So we've got x plus b over 2a squared. That's going to be equal to b squared minus 4ac divided by 4a squared. So we've simplified that right-hand side as much as we can. The next thing to do is to start getting rid of the stuff around the x on the left-hand side. So the first thing we can do is get rid of the squared, which becomes the square root. So that means x plus b over 2a. That's going to be equal to the square root, which is a plus or a minus, of b squared minus 4ac divided by 4a squared. We can simplify this a bit more. So carrying on over here, if we square root the top, so that means it's going to be x plus b over 2a. That's going to be equal to plus or minus the square root of b squared minus 4ac. And if you think about this bottom bit, so the square root of 4a squared is just going to be 2a. So we're going to simplify that to 2a. We're then going to move this last bit to the other side. So x is going to be equal to negative b over 2a plus or minus the square root of b squared minus 4ac. All of that is divided by 2a. These have the same denominators, so we can merge them together. And this hopefully should finish up our proof. Negative b plus or minus the square root of b squared minus 4ac. And all of that is divided by 2a. And it doesn't look like there's any other way we could simplify that. So I'm happy with that. So this equation here, right at the very end, this is the bit that you guys need to know. But hopefully you realize that this equation just doesn't come out of thin air. It's a manipulation of our initial quadratic, which we started with at the top. So if you can figure out the a, the b, and the c value of a quadratic, you can plug that into our end formula, which I'm drawing lots of arrows around. You can plug that in and that'll reveal the answer or answers to x. So hopefully you found that interesting. So what I'm going to do is I'm going to get you to pause the video. I'm going to get you to write down this proof because it's really important that we understand where this came from. And then I'm going to clear this proof and we're going to get into applying a couple of questions to this formula that we've just learned about. All right, guys, pausing now. Okay, so we're back, and I've just written in green that quadratic formula that we all need to know of, and we're going to get into a couple of scenarios. So the first one we're going to look at is just an easy one, x squared plus 5x plus 6 equals 0. The reason I've chose this one, just because it's easy to see, if you factorize, you should get x plus 2, x plus 3, and then our two answers should be negative 2 and negative 3. So let's see if the quadratic formula will get us to the same answer. So the first step is to figure out what the a, the b, and the c values are. So we need to know a, we need to know b, and we need to know c. And this time around, there's nothing in front of the x, which means a will just be 1. B is going to be 5, and C is going to be 6. So we're going to plug each of those three numbers into our quadratic equation. So x will be equal to negative b, so that's going to be negative 5. And I tried to put everything in brackets just to avoid making any silly mistakes. We're going to go plus or minus 5 squared minus 4 times 1 times 6. And all of that sits in the square root sign. We're then going to be divided that by 2 times 1. We're now just going to look to simplify, so that's negative 5 plus or minus 25 minus 24, and that's going to be divided by 2. So we've got negative 5 plus or minus the square root of 1 divided by 2, and from here we're just going to work out the two solutions. So x1 will be equal to negative 5 plus the square root of 1 divided by 2, which is going to be negative 5 plus 1 over 2, which is equal to negative 4 divided by 2, which is equal to negative 2. And that matches our first answer that we were expecting. We can then do the same for the second value of x. So we did a plus sign. We're now just going to do it with a minus sign. So x2 is equal to negative 5 minus the square root of 1 over 2. That's going to be negative 5 minus 1 over 2. That's negative 6 over 2, which is negative 3. And that matches the second answer we were expecting. So hopefully you can see how this works. All you've got to do is find the A, the B, and the C values. And then that lets you figure out the X value for these. So what I'm going to do is I'm going to clear our screen. We're quickly going to go through 2 more examples that are just interesting and have some quirks. And then I'll let you guys get into heaps of practice. Example number 2, quickly get the pen mode back in. So example number 2, we've got x squared. Oh, actually, let's change that. So we've got x and then x plus 4, that there is equal to 0. So it's not always going to look like the form that we need. And if that's the case, we just need to do a bit of algebraic manipulation to make sure we get there. So when we expand this, that's going to be x squared plus 4x, and that's going to be equal to 0. In this case, I just want to note, where's that c value? There is no c value there, which means that's going to be equal to 0. So this is just one of the things people get confused with. And also, if they look like x squared minus 9, again, in the middle, that b value is equal to 0. But in this case, we're dealing with the c. So we know that a is equal to 1, b is equal to 4, and c is equal to 0. So we can plug all of those into our equation. So x is equal to negative 4 plus or minus 4 squared, which is 16. And then we've got minus 4ac, which is going to be 0, because anything times 0 is 0. And then we've got divided by 2a, which is 2. So we've got negative 4 plus or minus the square root of 16 divided by 2. x1, we'll do the positive version first, plus the square root of 16 divided by 2. So it's going to be negative 4 plus 4 divided by 2, which is going to be 0. So that's our first answer. Nothing wrong with that. That's a good answer. A lot of people get confused. Oh, why is it 0? But 0 is still a number as well. We're then going to look at the second version, or the negative ones. We've got negative 4 minus the square root of 16 over 2. That's negative 8 over 2, which is equal to negative 4. So those there are our two answers. And that makes sense, because if you split the factorized version up here, x would have been equal to 0, which gets our first answer, and x plus 4 would have gone to minus 4, gets the second answer. Okay, awesome. So what I'm going to do is I'm going to clear this one, and then we're going to go one final question, and then we'll finish off our video. So we're up to example 3, and we're just going to put something in front of that. So we're going to have x squared plus 11x, and then we're going to have minus 4. And that there is going to be equal to 0. So A will be easy, B is easy, and C is going to be easy as well. So we don't need to do any rearranging, but we know A is equal to 3, B is equal to 11, and C is equal to negative 4. So we're going to plug that into our quadratic equation. So x is going to be equal to negative b, which is going to be negative 11, plus or minus b squared, which is 121, minus 4 times a, which is 3, times -4. And this is where the brackets comes in handy, because we do have a negative number. People are likely to make mistakes at that particular point. Divided by 2a, which is 6. So let's carry on. So we've got -11 plus or minus. So let's figure out what all this comes to. So we've got -4 times -4, which is 16. That's times by 3, which is going to get us to 3248. So we're going to be adding positive 48. So 121 plus 48 divided by 6. That's going to become -11 plus or minus the square root of 169. That's going to be divided by 3. Oops, I've written 68. 69. Divided by 6. That's going to be -11 plus or minus the square root, plus or minus 13, because that's the square root of that, divided by 6. So we're going to have x1 will be plussing it, which will be 2 over 6, which is 1 over 3, and then x2 will be equal to minus, that's -24 over 6, which is -4. So hopefully you found this video useful. The only additional thing you might need to know is the numbers we all looked at were numbers that could be square rooted. But for example, if we had the square root of 8, you would just calculate that as its decimal, whatever that is. I made up the numbers, and you'll be using that number to add or minus. So longer video today. Hopefully you found it useful. We learned how to prove the quadratic formula, and then we learned how to use the quadratic formula to solve quadratic equations. Let's get into heaps and heaps of practice now.